So, if you know what we did last week, especially for the people who were not here, you must do your brackets first. Brackets don't matter what. I have 2 Liams during the class today. Liam and Liam. Brackets first, right? You all knew this? Raise your hand if you knew this. You all knew brackets first, right? Okay. Then, even in the brackets, we have an order for our operations, right? You must do multiplication and division before addition and subtraction. So everything Gabriel said is correct, right? So this will be equal to 7 plus 15, which will give me, how much I got, Gabriel? 22?
Yes, sir.
Perfect. Perfect. Let's go to Kimani. Next one. What we doing here, Kimani? This is the easy stuff. Let's go.
So first is 6 multiplied by 4. I get a 6 from 8, take away 2, and multiply it by 4, which is 24.
Come out today, boy. Makai.
Sir, I have a mixed homework.
You do, but is it 2 worksheets we have to do now, bro? Is this worksheet and it have our next worksheet we were supposed to complete? So did not see this one?
No, sir.
All right, but let's do it. Look at the question, Makai. We're on part C. What do we need to do here first?
First, sir, you have to add 9 and 6, which will be 15 divided by 3, which will be 5.
Excellent. Hold on, guys. Hold on. I just want to settle something for my son here.
So what I do is 7 take away 3 is 4.
Yes.
And then 4 plus 10 is 14.
Excellent. So we did the brackets first. Guys, you all realize that this, lucky, né? You all realize that these questions are simple questions. The concept that I'm trying to drive home is that 1, you must do your brackets first. 2, you must do multiplication and division before you do addition and subtraction, right? I see Lucas watching this like it's a hard question by Lucas, boy. You think you can handle E, Lucas? Liam. Is he not hearing me? Liam. Anybody else hearing me?
Yes, sir.
Yes, sir.
Why you not hearing me? Liam Lucas. Liam not hearing me, you know? Look, Liam, you might have to leave and come back. One message. Yeah, he did that. Leave and come back. Let's go on to Thornton. Let's go. What we doing here first, Thornton?
The brackets.
Right, so let's work Thornton. So let's do it piece by piece. So which one? Come on, guide me. So I'll put back the square brackets, right? Because we're not dealing with that yet. So let's go.
8 divided by 4 is 2.
So I put 2 plus 3, right? And I put back the other square bracket. Then I put multiply. What are we doing in the square bracket here?
6 plus 1. No, 10 minus 6 plus 1.
Right. Well, 10 minus what?
10 minus 7.
Excellent. Oh, this is a square bracket. Right. Let's deal with the 2 square brackets now, Thornton.
2 plus 3 is 5.
Right. So 5 multiplied by
3.
Which is
15.
Right, let's go. Who is in under the name Madonna V? I see Madonna V.
Yes,
Who's me? Alex.
Alex.
Yeah, Alex,
Yeah.
You had to fix that name, bro. You had to fix that name. Now, Alex, I don't think you were here last week, right? But still, I wanted to watch this here. They want us to list the factors of the numbers 24, 36, and 45. I want you to do 24, Alex. So, did you go through the recording from last week, Alex? Because I know you weren't here for the class. Did you go through the recording and see what a factor is?
No, sir, I didn't get you recording.
All right, Zaya, I want you to tell Alex what a factor of 24 is, please. Zaya, sorry.
So tell me what a factor is?
Yes, what is a factor of 24? A number that could what?
A factor is a number that can be divided exactly into a given number.
Exactly. Very good. So a factor of 24 is a number that can be divided exactly into 24, right? So give me them, Zia. What are the factors of 24?
1, 2, 4, 6, 3, 8, 24.
You're missing one. 12. Right, Zia? Right, Ramdas, 36. Let's get the factors of 36 or the numbers that can divide exactly into 36 without a remainder. Ramdas. Ramdas.
Right. For factors of 36 will be
Yeah. Yeah, 1.
Right. 1, 2, 3, 4, 5, 6,
Not
9,
5, not 5.
12, 18, and 36.
Not 5,
Oh.
bro. 5 cannot go to
6.
36. Right?
6, 9, 12, 18, and 36.
Right? You missing any? Let me just make sure we are missing any. Yeah, that's it, right? Right, let's go. C. Let's go to Taylor. What are the factors of 45, Taylor? Factors of 45. Taylor.
Say, Emerson?
Yeah, loud and clear, bro. Factors of 45. I'm not hearing you, Taylor. I'm not hearing you now. All right. Amani, Bob. I'm gonna check Amani. Amani, Bob. Factors
Yes,
of 45.
sir.
Come on, we gotta move a little faster. We gotta move a little faster. Factors of 45, Amani, Bob.
Yes, so the factors are 45.
Yeah.
So the factors are 45 are 1, 5,
My person.
3, sir.
Yeah.
Wait. Sorry, so my book just not so long. And my phone too. Yeah. 45, so 6, sir.
6 go to 45, you sure?
Wait, no, sir.
This was supposed to be homework, okay, brother?
Yes,
All in that effort.
So 54, 45.
54?
Oh, so you said 45, so I was saying 54.
You're killing me no, Amani. What are you saying? I don't know what you're saying. 54 is a number that could go into 45, bro?
No, so which multiples you're saying, 45 or 54, sir?
45. What's your screen, Amani? What's your question we doing?
All right. Yes, sir. 1, 3, 5,
Yeah, no problem, Taylor. Yeah, 1, 3, 5, yeah.
9, 15,
Right. 15, right.
and 45, sir.
Right.
All right.
Right. So these are factors. Factors are numbers that can go into my given number exactly without a remainder. Now we're going to deal with multiples. Find the multiples of the following numbers up to 40. So you're not listing a multiple that is greater than 40, right? So let's go to Stefan. Stefan, that's Sheldon. Sheldon, Stefan. Right, let me go with 5, Stefan.
5, 10, 15, 20, 25, 30, 35, and 40.
Right, let's go. Liam Regard. That's Regard. That's how you pronounce that. What are the multiples of 7, but you're not crossing 40?
Rigu. It's Rigu.
Rigu. So Liam Rigu.
Mm-hmm.
So multiples of 7, but don't cross 40. Let's go. List them.
14, 21,
Well,
28.
7 is a multiple of 7, bro.
Oh, true.
Right? So we start with 7.
14, 21, 28, 35.
Right. Samaya, multiples of 10, but don't cross 40. Samaya.
Multiples of 10 that don't cross 40 are 10, 20, 30, and 40.
Right. So they said identify whether these numbers are prime or composite. Lucas, you know what a prime number is? I know you're now coming into the class. You weren't here last week. What is a prime number? A number that what?
A number that could only be multiplied by itself or 1.
Okay. All right. So it's basically a number that only has 2 factors, itself and 1, right? Those are the only 2 numbers that can go into that number. So Lucas, is 17 a prime number?
Yes, sir.
Prime. Lucas, is 29 a prime number or a composite number?
A prime number, sir.
Proper thing, Lucas. And 51, composite or prime?
Composite.
Now, a composite number is simply a number that has more than 2 factors. Operative word here is factors, right? Composite. Right? Everybody's supposed to be working here. I want to pick up the momentum all here. Right. Find out the highest common factor. So we're going to work HCF, right? Now we work in these HCFs, and I want to use the prime factorization method that we used in class last day. So we're going to list the prime factors of each number here, right? So we started with 6. What are the prime factors of 6, Gabriel? Come on, let's try to pick up this pace. What we started with? 2 or 3?
2.
Right? 2 into 6 is?
3.
And 3 into 3 is?
1.
Kimani, 12. What we starting with?
2 into 12, 6. 2 into 6,
6,
3. And 3 into 3,
1. All right, that's why I like my students functioning. Makai, 18. What we starting with? 2 or 3?
2, sir.
2 into 18?
9.
And could we use 2 again?
No, sir. You use 3.
3 into 9 is?
3.
And 3 into 3 is?
1.
Right, so we're going to list our 3 numbers as a product of their prime factors, right? So I'll have 6 is equal to 2 multiplied by 3, which is this 2 and this 3 here. Let me highlight it, in case you're not seeing it. 2 multiplied by 3. And then for 12, 12 will be 2 multiplied by 2 multiplied by 3. And then 18 will be 2 by 3 by 3. Let me write it down. So 12 will be equal to 2 multiplied by 2 multiplied by 3. Right? And then 18 would be equal to 2 multiplied by 3 multiplied by 3. So let's go to Jackson. What are the common factors here? So let's list the common factors, right? 2, so you're going to put 2 multiplied by what's the next common factor?
3.
1 of the 3s, then? Not 2, not 2 3s, right? 1. Okay? So 2 is common and 3 is common, so we put 2 multiplied by 3. So therefore, my HCF here would be 6. Raise your hand if you got 6, please. Raise your hand if you got 6. Proper thing, we working. Right, so I want one person to list all this to me here. Turn, let me go. Give me the prime factors, turn, because I think everybody more or less have the working done. What are the prime factors of 15? It will be what? 3 multiplied by?
5.
Right, and for 20, what is it?
2.
Thornton, you got 2 multiplied by?
10.
Prime factors. 10 is not a prime number. Thornton, I chose not to do the workers because I wanted to try to fast track it, but let me do it. So 3 into 15 was 5. Then we said 5 into 5 is 1. That's where we get 3 multiplied by 15 from, right? Then for 20, Thornton, 2 into 20 is?
10.
And then what we using? Could we use 2 again?
Yeah.
2 into 10 is?
5.
And then 5 into 5 is?
1.
Right, so you're going to put 2 multiplied by 5. And then let's go for 25. Let's get Alex. Alex, what's the first prime number that could go to 25 here? Could 2 go to 25, Alex?
Yes, sir.
Yes or no? No, 2 cannot go into 25. Right? Could 3 go into 25, Alex?
No, sir.
Right, very good. So the next prime number that could go to 25 is 5. 5 into 25 is what, Alex?
5.
Right. And then 5 into 5 is?
1.
Right. So we're going to write 25 as 5 multiplied by 5. So what's the only factor that is common here, Alex? So it's HCF, the highest common factor. Which factor is common here, Alex?
5.
Yes, is just 5. Watch. Okay, you have a 5 there, you have a 5 here, and well, one of these 5. So 5 is common, therefore my HCF is nothing else is common. So it's just 5. It's not 5 multiplied by nothing or anything because 3 not common, 2 not common, right? So that's my HCF. Raise your hand if you got this, please. Right? Those who need to write, because this is homework, if you need to write and I'm moving too fast for you, just go to the recording after and you could fill in the spaces, right? Okay, because I need to move it a little pace because this is homework. At no point in time must we take more than an hour correcting homework. At no point in time, right? So let me go. Who that was? Zia. Zia, can you just give me the prime factors of 21? Yes. If you worked it already. Prime factors of 21.
Sir, I don't have it.
How many people did this homework? Raise your hand. If you did these questions here. All right, so Zia, you're going to work it for me on the spot. Zia, next time, all that a whole week, right? We need to get our homework done. What's the first prime number that could go into 21, Zia?
3.
3 into 21 is? Zia.
Yes, sir.
3 into 21.
7.
And 7 into 7 is?
1.
So this will be 3 multiplied by 7, right? Ramdas, 28. What are we using here, Ramdas?
So 2 and 7.
2 into 28 is what?
I got be 14, sir. I get.
Right. And you don't give me the answer there. 2 by 2 by 7. Yeah, very good. Right. So 28 would be equal to 2 multiplied by 2 multiplied by 7, right? That's Jahim Ramo in class right now?
Yes, sir.
Right. Okay. All right. Your mommy no message my here now. Okay, no problem, mommy. All right. So last one, 49. 49. Who's the last person I call on? Ramdas, give it again now. 49. What it is here, Ramdas? What are we using first?
So I do 7 times 7.
Yeah, 7 into 7.
That's 7 and
1
7.
here. So Amani, what is my HCF here, Amani?
So your highest common factor is 28, sir.
28, and how you get 28, brother?
Wait, no, sir. I was gonna do a thing. 49.
Right. So the answer here for part C would have been 7 because 7 was the common factor, right? Now we're gonna deal with LCM. We could do LCM just as we do it for primary school, right? So you line it up. If you want to find the lowest common multiple of 8 and 12, just like primary school, you put the 8, 12, right? And you divide it until you get 1 and 1 at the base, right? So let's go to Liam is Rigud, I think he said Rigud. What's the first? Well, same thing, prime factors we roll in with, right? What's the first prime number we can use here? Could 2 go into anything here?
Yeah.
Huh? Right,
Yeah.
so you use 2. So the thing about finding the LCM, you use 2 till you can't use 2 anymore, right? So 2 into 8.
4.
Right, and 2 into 12.
6.
Right. Could we use 2 again?
Yes, sir.
So you go with 2 again. 2 into 4.
2.
2 into 6.
You bring down the 6. No, 3.
No, 3, right? Could we use 2 again?
No. Yes.
Yeah, 2 could
Yes.
still go to something here. 2 into 2.
1.
Bring down the 3 because 2 cannot go to 3, right? And then what do we use now?
3.
3, well, you bring down this 1. 3 to 3 is?
1.
Right, primary school way to do LCM is this, right? So you're just multiplying all these numbers here, just like we did for the prime factors. So it's 2 multiplied by 2, multiplied by 2, multiplied by 3. You get 2 to the 3rd power. 2 2s are 4, 4 2s are 8, and 8 by 3 would give me 24. So 24 would be my LCM here. Raise your hand if you got that, please.
Excuse me, sir.
Yes, go ahead.
Can I take off my camera, please?
Yeah, go ahead, Anita. Right. So we're going to the next one. Let's go to Samaya. Right. So I'm lining up the 3 numbers that we want to find the LCM of, right? 15, 20, and 25. Can 2 go into any one of these, Samaya?
2 can go into 20.
So you use 2. Once you can use 2, you have to use it, right? I bring down the 15 because it can't go into 15. 2 to 20 is?
10.
Bring down the 25, right? What we use the next?
You can still use 2 for the 10.
Excellent. So 2, bring down the 15. 2 into 10 is?
5.
And then 2 can go to 25, bring down the 25. So what we use the next? Can 3 go? We go to the next prime number. Can 3 go into anybody here?
It can go into 15.
So 3 into 15 is?
5.
And bring down this 5, bring down this 25. What we use the next, Samaya?
5.
5 into 5 is?
1.
Excellent. 5 into 5 is?
1.
And 5 into 25 is?
5.
And 5 for this last step. So you get 1, 1, and 1. So therefore, my LCM would be equal to you multiplying all these numbers here, right? So it'd be 2 by 2 by 3 by 5 by 5, right? 2 2s will be 4. 4 3s are 12, right? So it'll be 12 multiplied by 5 5s are 25. And 12 multiplied by 25 will give me what there, Liam Lucas? 12 multiplied by 25. Something wrong with Liam Lucas, Mike, you know. Taylor, 12 by 25. What are you getting there?
300, sir.
300 flat. Right? What I did, I multiplied these 3 here first. right? And then I multiply these two, and then I multiply them out, right? Lucas, you hear me?
Yes, sir.
You hear me just calling your name?
No, sir.
So that means you didn't hear me then. Or you train. You train where, you know, if somebody calling you do like if you didn't hear them. You train Liam Lucas?
No, sir.
All right, brother. Right, so we good there. Last one. Come on, we're taking too long on these things, eh? This is HW. This is homework. Right, let me jump here. Liam Lucas, what we using here first? We want to find the LCM Liam Lucas.
So 2.
Right, so let me go. So so this is 24. So 2 into 12.
6.
2 into 18.
9.
And 2 into 24 is
12.
We're using 2 again. Let's go. Give me the numbers underneath here.
3, 9, and 6.
Right, you bring down the 9. Could we use 2? We could still use 2, bro?
Yes, sir.
Let's go. So this will be
3, 9, 3.
3. Excellent. Then we use 3. What we get underneath here, my brother?
1, 3, 1.
And we're using 3 one more time.
Get
right?
1, 1, 1.
1, 1, 1, right? That's the whole mission. So there we go. Therefore, my lowest common multiple will be equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. What my answer will be here, Taylor? Taylor. 2 by 2 by 2 by 3 by 3.
72.
Somebody second 72. Raise your hand if you got 72. What is the smallest sum of money that can be made up of an exact number of 10-cent pieces or of 25-cent pieces? Now, they said the smallest sum. So what are we using here, Ramo?
Lowest common factor, sir.
Lowest common factor. You sure it's lowest common factor?
Yes, sir.
It have a LCF then. You say lowest common factor, you know? What is lowest common what?
Multiple.
Right. Lowest common multiple. Once you see the keyword small, are you looking for the smallest sum? Right? It's the lowest common multiple. If you see highest, biggest, maximum, it's highest common factor, right? So it's simply a LCM question, right? So we're going to have 10 and 25. So I'm just going to work it out fast, right? Because I want to kind of amp up the pace here because I want to do fractions today, right? So 2 into 10 is 5. You bring down the 25 because 2 cannot go into 25. Then we use 5 next. 5 into 5 is 1. 5 into 25 is 5. We could use 5 one more time. Bring down the 1. Bring down the 5 into 5 is 1. So therefore, my LCM would be 2 multiplied by 5 multiplied by 5, which will give me 5 2s are 10. 10 by 5 is 50. Raise your hand if you got 50, please. Kimani, the smallest length that can be divided exactly into equal sections of length 5, 8, or 12 meters. What do we use here to find out that smallest length here, Kimani?
LCM.
LCM. Once you see those keywords, you have your keywords, learn those keywords, right? We're using LCM, right? So I'm going to put 5, 8, and 12 here, and we need to find the LCM. Going to move through it a little fast because I want us to go on, as I said. So we can, 2 cannot go to 5, 2 into 8 is 4, 2 into 12 is 6. We use 2 again, 2, bring down the 5, 2 into 4 is 2, 2 into 6 is 3. We can use 2 one more time. 2 into 2 is 1. You bring down the 3, then you use 3. Right? You get 5, 1, and 1. And the last thing you're going to use is 5. 5 into 5 is 1. You bring down this 1 and 1, right? Boom, bang. Therefore, my LCM, we multiply all the prime factors, which will be 2 by 2 by 2 by 3 by 5, which will give me what there, Makai? What you get,
120, sir.
120, bro? Is 120 you said?
Yes, sir.
Somebody second this. A room measures 450 centimeters by 350 centimeters. Find the side of the largest square tile that can be used to tile the floor without any cutting. So we're looking for the largest square tile. Keyword here, largest. What do we use here, Thornton?
HCF.
So in order to use HCF, we need to list the prime factors of each number for the lengths that we were given. So 450, what do we start with?
50.
No, start with the smallest prime number. Could 2 go into this?
Oh yeah, 2.
So 2 into 4 is 2. 2 into 5 is 2 also. Remainder 1. Then 2 into 10 would give me 5. So you have 225, right? Could 3 go into this, Thornton? Because 2 cannot go into it, right? But can 3 go?
No.
You sure?
Yeah. No.
Watch it.
3
cannot go into 2, right? But 3 into 22 is 7 because 7 3s are 21, remainder 1. And then 3 into 15 is?
3 into 15 is 5.
Right, so that's how we get 75 there, right? Could 3 go again, Thornton? Could 3 go into 75?
Yeah.
Huh?
Yeah.
Yeah, 3 could go to 75. So 3 into 7 is 2, remainder 1. I'm going to put the 1 right here. 3 into 15 would be 5. Could 3 go again, Thornton?
No.
Right, so 5 into 25 is?
5.
And then 5 into 5 is?
1.
Right, so the prime factors for 450 would be, we're going to list it underneath here, right? So 450 would be equal to 2 by 3 by 3 by 5 by 5. Now we're going to list 350, right? Let's go to Alex. Alex. Could 2 go into 350,
Yes, sir.
Alex?
Yes, sir.
2, yes. So 2 into 3 is 1, remainder 1. You put that 1 here. 2 into 15 would be 7 because 7 2s are 14, remainder 1 again. And then 2 into 10 would be 5, 175. Now we know 2 cannot go into 175, but can 3 go into 175? Alex?
No, sir.
No, it can't.
No,
so we go to 5. 5 is the next prime number. 5, we sure 5 could go, right? So 5 into 17 is 3 because 5 3s are 15. Remain now 2. 5 into 25 would be 5, right? Could we use 5 again here, Alex?
Yes, sir.
5 into 35 is 7. And then 7 into 7 is 1, right?
1.
So let's go to Amani Bob. Right? Amani.
Yes,
HCF we try to find. I'm going to write out 2 by 5 by 5 by 7, right? So we have the prime factors of 450. We have the prime factors of 350. What would now be the HCF of 450 and 350, my brother? What's the HCF here?
The highest common factor is 5, sir.
5. So you're seeing 5 here, 5 here. Nothing else common, bro?
And 3, sir.
3. You see that 3 in this? You see that 3 underneath there?
Oh, no, sir.
But watch, our next 5 common, watch. Look, 5 and 5 here again. So you can say 2 5s are common. Therefore, your HCF would be 5 multiplied by 5, which is 25.
25,
That's
sir.
right. So there'll be 25 centimeters is the largest length that we can get for this tile. Well, this tile that we want to tile the room with, right? Okay, so raise hand. Anybody was able to get this? And 54 chocolates. If we're looking for the greatest number of children, what do we use here, Zia?
So repeat it.
Huh?
Repeat what you said.
We want to find the greatest number of children that can equally share 72 sweets and 54 chocolates, right? What do we use?
Division.
Say that again.
Division.
What division?
What is it, sir?
What division are we speaking about here? Oh, what's the first thing? We need to find the HCF because they ask us the greatest number of children, right? So greatest is one of the keywords that implies HCF. What's the first thing we need to do to find the HCF here, Zia?
Yes, sir. And
Okay, so we go
2 into 72
2 into
is 36.
72 will be 36. Then you can use 2 again. 2 into 36.
2 into 36. 15.
18, right? And then 2, you can use 2 again. 2 into 18 is 9. And then 3 into 9 would be 3. And 3 into 3 is 1. Right?
Yes.
So the prime factors of 72 would be equal to 2 by 2 by 2 by 3 by 54. 3 into 27 is 9. Then you can use 3 again. 3 into 9 is 3. And 3 into 3 is 1. So I'll write 27 right underneath here. So it'll be 2 by 3 by 3 by 3. Right? So therefore, what is my HCF here, Lucas?
So 18.
18 is the HCF. I'll just go and highlight what's common. We have 2 common, right? So I'll write it down 2. Right, Lucas? I'll put 2 here. All right? 2 is not common again. We don't have our next 2 to match this to it. 3. One of the 3's is common. So I'll put that 3 here. And then our next 3 is common. All right? So yeah, it works out to be 18. Very good. All right? So another 3 is common. So I've multiplied by 3. And this will give me 9. Not 9, right? 9. 9 multiplied by 2 is 18. That's my HCF. Right? Right, so let's just run through these, right? So we have some practice questions here. I gave you all this homework also. By the way, raise your hand if you did these. Raise your hand if you did these. Because some students' parents message me this one and tell me that they didn't see it. All right, good. There you go. So we run it.
This is the only homework sheet, I guess, sir.
Oh, okay.
Excuse me, this was also homework?
Yeah, this was also homework. And the 2 worksheets that I sent in the group had homework on it. 2 worksheets. Right, so let me go. So this will be 6 plus 12, which will give me 6 by 12 is what, guys?
72.
Not by, sorry,
18.
plus. Yeah, 6 I've all by is plus. Sorry. Let's make a mistake there. Right. So let me go. 6 plus 12 will be 18. Right. I feel like just give me the answers here now. What's the answer for B? Somebody give me the answer for B. And let's see if we can just get somebody to second it. 13, 1, 3?
30.
3, 0. Somebody second 3, 0. Everybody good there?
Yes, sir.
Right. Now, C. Answer.
35.
35. Somebody second 35, you sure? That's 35 and song, right? What you got for C?
So I got 55, sir.
30, sir.
18 plus 12 is what?
20.
18 plus 12 is 30.
30.
30 divided by 6. Well, again, 35
5.
times.
No.
5.
So I get 5.
All right.
Green 5s
Yeah, I
are
get
not
5.
usually question.
Okay, for part D. Just give me the answer for the first bracket. 5 plus 2 is 7.
7.
And then 8 minus 3 is
5.
5. Guys, sometimes these things just be easy questions, but I'd like to hear all your answer. 7 5s are?
35.
35.
Right, let's go.
35.
Yeah, we had to move a little faster. Right, let's go. I'll put in the square bracket. So 10 divided by 2 is?
5.
5 plus 4 here, multiplied by 12 minus 3 plus 2 is?
5.
Right, so first square bracket, 5 plus 4 is 9. 9 multiplied by 12 minus 5.
7.
9 sevens are? 9 sevens.
63.
63,
Right.
sir.
63. Let's go.
63.
Excellent. So this will be, working on the brackets first, so it'll be 9 plus what?
9 plus 16.
16.
Minus 6, right? 9 plus 16 would give me what? 25? 9 plus 16.
Yes, sir.
25. 25 minus 6 will give me
21. I mean 19.
19. Right, move in. Right, first square bracket here. So this will be equal to 6 plus 2 is 8. 8 multiplied by 3 is in the square bracket. And then what do you get there? Divided by 2. 8 threes will be?
24.
8 threes are? 24 divided by 2 would give me?
12.
Excellent. Move in. 15 minus 5.
10.
10.
10 plus? Come on, Leon, 10 plus?
8.
10. All right, 10 plus 8 is?
18.
All right, next one. This will be 20 divided by?
10.
All right, right, that's one. All right. 20 divided by 10 plus 7. What are we doing here first? 20 divided by 10. You do division before you do addition, right? Where you get?
2.
2 plus 7 is?
9.
9.
Right, proper. 9. Right, so let's do the square brackets here. 7 twos are?
14.
14.
14 minus 4 here. Then multiply by what?
6. Divided by 3.
2.
2.
Yeah.
6 divided by 3 is 2. Right. 14 minus 4 is?
10.
10.
10 multiplied by 2 is?
20.
20.
Right. Who got all those correct there, number one? Raise your hand if you got those. Right. So we want the factors of 30. Let's go. Factors of 30.
1, 3, 5, 6,
I hear somebody bought 2. Right, go ahead. 6. There was?
10,
Uh-huh.
15, and 30.
Anything missing here, my children? Anything missing?
2, sir.
Yeah, put in 2. Look, 2 here. Put in 2. Right, so we good there, right? 42. Let's go. 42.
Let's go.
Factors of 42.
1.
1,
7.
2, 7, yeah.
6. No. 6. No.
Yeah.
6. 8.
8.
I'm mistaken.
Nah, not 8. Not 8 at all.
No, I think I'm mistaken.
Come on, what's the other factors here? What missing?
7, 3, and
7.
42.
3. 3 could go into this here.
And 42.
No, something's missing here, boy. We're missing some factors here, guys. 21. I hear somebody say 21. Very good. Something else missing.
12.
12. You sure it's 12? I don't think it's 12.
No. 4, sir.
No, not 4.
Sir,
All
9.
it guessing. All the guessing.
Say
Watch it.
12.
No, not 12. Not 12 at all.
42.
We already have 42. Watch it, eh? How you can check back this, right? You can say 1 into 42 is 42. So you know you have 1 and 42. Then 2 into 42 is 21, right? You have the 21 here. Then 7 into 42 is 6, right? You have the 6. It's like you had the match up now. 3 into 42. How much times 3 could go into 42, guys? Nobody wrote down the what 3 into 42 is what?
So 14.
14, thank you. Right? That was the missing one. Right? Next time all I had the answer, tell me. Right, let me go. 54. Come on. Belt it out, guys.
1,
You sticking, eh? 1, excellent.
2,
2, very
3,
good. Very good.
9.
9, you say?
Yes, sir.
Right, 9. I hear somebody say 6. Yeah.
54.
Yeah, 54 there. Plenty things missing. What missing?
So 18.
18.
27.
27. That's it? I think that's it. Yeah? That's it, right, guys? You missing anything? Raise your hand if you have all these here. 16? 16. No. No, 6 4s. That would mean 4. 4 into 9, not 16. Right? Raise your hand if you have all these, please. Right, last one. No, we have 2 more. 60. Come on. You're trying to put them in order now. Let me go. 1, 1, 2, 1 extra.
3.
4. 4 could go also.
6.
5.
5 and
6.
6.
Right.
10,
Well, 10.
20.
12.
20.
15. I'm trying to go in order because when we didn't go in order above, like you're missing some. 15. After 15. 20.
20.
Yeah, well. 30. And then 60,
And then
right?
60.
Yeah, right. Let me go here now. 1, 3, 5. What else we have?
15.
15. Yeah.
25.
25. Right. Excellent. What next? And 75. That's it there, right? Okay. Multiples of 6. Now these shouldn't be hard, eh? We just listen to multiples of 6 up to 50. We're not crossing 50. So let me go. Somebody give me the say. So for 6, what would it be? 6 is that like a 6 times table? 6 then what? Let me see following all the tables. 6 then 12,
18.
18,
20.
24. 30. 36. 42. 48.
That's it. The next one would cross 50, right? Let you go. 8 times table. We started with 8. The multiples of 8. 8 then
16.
16, 24, 32, 40, 40.
48.
nothing else, right? There's that good little tables times tables worksheet there. Let you go. 9 then
18.
18,
27.
27,
36. And 45.
45. Nothing else, right? 45. All right. All right, let's go. 4,
8.
8.
8,
12.
12,
16.
20,
24.
28.
28.
32.
36,
36.
36.
40.
44,
44.
48.
40.
48. Right? Let me go 12 times table. 12.
12,
24.
24, 36, 48.
46,
Talk done.
48.
Right. Identify whether these numbers are prime or composite. What this one is?
Prime.
Come
Prime.
on. Prime.
Prime.
This is prime? This is prime?
Composite.
You sure?
Composite.
Composite.
Why is it composite? Who can tell me why is it composite?
Because
It have
11
more
and 3
than
could go into it.
Exactly. Very good. We have more than 2 factors, right? 11 and 3 can go into it. Prime or composite?
composite.
Excellent. Next, 41.
Prime.
Prime.
Yeah, this is prime. 57.
Composite.
Yeah, composite. Very good, my children. Right. Hey, Olia, who work it out, boy? I don't think we have time to work these. Let's give me the HCF here now. What's the answer? Let's give me the answer and let me see if you can get somebody to second it. What's the HCF here? Highest common factor. Who work it out? Oh God, don't tell me we have to go and work out this now, eh? Nobody work out this?
So I work it out.
Where you get, sister?
I get for 10, I got 2, 5, and 10.
No, I just want the answer. I want the answer.
The common factors are 2, 5, and 10.
2, 5, and 10.
And the HCF is 10.
Well, the common factors will be 2, 5, and 10. The common factors will just be 2 and 5, right? Or 2 multiplied by 5, which will give me 10, right? Raise your hand if you got the HCF to be 10 here. Right, what's the HCF here, Turn?
14.
So what you get, like 2 multiplied by 7 when you work it out? Turn.
I didn't work it out.
Huh?
I didn't work it out.
So how you find it? What was the working you put it? Let's put 14 as the answer.
Yeah.
You gotta put some kind of working, right? Okay? So
Okay.
this what I put here is what we did for the prime. You're supposed to work out your prime factors and then see which ones are common, right? So we need to do that. Let me go. C. Well, you all got for the HCF for C. That's giving me the 2 prime factors that they ultimately multiply. Or more than 2. It could be more than 2. What you all got here?
I got 2.
2 times 8. 2 times 8.
It can be 2 times 8 if it's prime factors.
I get 2.
I got 2.
2 alone?
Yes, sir.
That ain't song correct. All right, let me go. Let me work it out, right? So you're going to list the prime factors of each of these questions here, right? Let's go. So 16. 2, you start with 2. 2 into 16 is 8. 2 into 8 is 4. Then 2 into 4 is 2. 2 into 2 is 1, right? Then we go to 32, right? 2 into 32 is 1. Remainder 1. 2 into 12 is 6. Then you'll get 2, 8, 4, 2, 1, right? So it's 2, 2, 2. Plenty 2s. 2 into 48 is 24. 2 into 24 is 12. 2 into 12 is 6. Then 2 into 6 is 3. 3 into 3 is 1. So I'm gonna line up the three numbers as a product of its prime factors. 2 by 2 by 2 by 2. 32 would be 2 by 2 by 2 by 2 by 2. And then 48 would be 2 by 2 by 2 by 2 by 3. So if you listen to our HCF here, right? So if 2, you have 2 common, right? 2 is common. So let me highlight it, right? You have 2 common here. 1. That's 1. Is there another 2 common, guys? Ramdas, is there another 2 common here?
Yes, sir.
Right, so another 2. So we go down right that next to there. Multiply by 2. Is there another 2 common here, guys? Y'all seen
Yes, sir.
another 2
Yes, sir.
common? Yeah. And is there another 2 common? There's our next one actually. Right? I
Yes,
just showing
sir.
you all the working. Some people are able to just watch these things and see it, but this is the working. Right? This is the working. So that's it there. Nothing else is common. So 2 by 2 by 2 by 2 is equal to 16. 16 is your H. Let me just look at this. Right, HCF for this one here. Anybody got the answer? What is the HCF for D? Did anyone work it out? 9. Somebody second 9. Who else got 9? Raise your hand if you got 9. Nobody else get 9, boy. We had to work it if nobody else can get. We had to work it. That's what we had to do. Right, let you go. So we deal with 18 first. Could 2 go into 18? Can 2 go into 18, guys? Yes. 2 into 18 is
Yes, sir.
9. Then you go 3 into 9, 3, 3 into 3, 1, right? Then 27. You start with 3. 3 to 27 is 9. 3 into 9 is 3. 3 into 3 is 1, right? And then we have 45. We can do 3. 3 into 45 is 15. Then do 3 again. 3 into 15 is 5. 5 into 5 is 1. So we don't need to go and write it down as a product of prime factors. Here you can see them right here, right? So what is common here, Lucas? What common? You see that 3 common here, Lucas?
Yes, sir.
Right. It have our next 3 common. I should have do these 3s, boy. Look.
Yes, sir.
Right. Yeah. So the blue 3s, right? That's a 3 that common. And then this 3 common now. Look, 1, 2, 3. You have our next group of 3s that are common. So therefore, my HCF would be equal to 3 multiplied by 3, which would be 9. Okay? Everybody good here? What is the HCF of E? Makai, you work out E. What's the HCF of E? 25, 35, and 45. What you got there, bro?
15, sir.
15? Somebody second 15. Nah, that 15 ain't correct. Because 15 cannot go into 25, so I'm sure that's not correct. Anybody else got an answer?
5, sir.
Yeah, 5, right? So y'all, right, 5. 5 is the answer.
Sir.
Very good. So y'all work it, right? Wait, I'm actually gonna die, buddy. Hold on, guys. Right. Raise your hand if you work out these LCMs. Raise your hand if you work them out, because I just saw answers here now. Right, let me go. Part A, what's the LCM? Anybody? Anybody? Just give me the answer now, please. 7, how much? Raise your hand if you did this, guys. Right. So fractions is the topic that we will do today, right? Fractions, we're going to deal with addition and subtraction. Then obviously we'll move into all the other types, right? We have the mixed numbers, the improper fractions. We're going to do multiplication and division. Everything we're going to deal with, right? Now, for a fraction, you have your numerator and your denominator, right? In each of the following sketches, write down the fraction that is shaded. So a fraction, if we deal with a circle, a fraction is like a part of this circle, right? So for number 1 here, our circle is cut into 6 equal parts, right? So let's start with Amani. Amani, what fraction of my circle is shaded here for number 1?
1. So if you want to find out what part is shaded, it is 1, but you have to count the numbers that are not shaded. The numbers that are not shaded is 1, 2, 5, so, and the shaded one is 1, so that is 1 out of 6.
Right. It's simply 1 out of 6, right? Or 1/6 of the entire circle is shaded, right? Jackson, what fraction of the circle is shaded in number 2?
1/3.
1/3, right? For number 2, number 2 is underneath here.
Oh, so I didn't watch the number.
That's okay. For number 2, what fraction of my circle is shaded?
3/8.
3/8, right? Because you have 8 slices, is like slices of a pizza, right? You have 8 slices, 3 out of the 8 slices are shaded, right? Then for number 3, what is number 3? Alex. Alex, what's number 3? Alex, right? Alex. Ramo.
1/3, sir.
1/3 because 3 parts in total, 1 part shaded, right? Kimani, 4.
Oh, 5 out of 6.
5 out of 6 or 5, 6, right? Makai, 5.
2 out of 6 or
2.
1/3, sir?
Right, 2 out of 6, which can be reduced to be 1/3, right? Because 2 into 2 is 1, 2 into 6 is 3. All right, very good. Thornton, number 6.
7/10.
7 out of 10 slices of the pizza are shaded, right? Everybody good here, right? Is anybody still not understanding how we identify fractions from a shape? All right, everybody good here. So we move in, the train is moving. Right, so it is not only cakes that can be divided. Well, I say pizzas, but they say that it's not only cakes that can be divided into fractions. Anything at all can be, well, divided into a fraction, right? So write down the fractions of the shaded region. So let's try to move a little faster, right? Number 7, Liam, Rikud.
Rigu, a quarter.
Rigu, quarter. Lucas. Where's Lucas? Why Lucas camera not on? Lucas.
Yes, sir.
Number 8.
3/4 or 3/4.
3/4. Alex, number 9. Alex, number 9.
1.5. 1.5.
1.5, you sure, bro? What fraction of that shape is shaded there, Alex, at number 9?
So 1.5.
1/2, bro. Yeah, 1/2.
Yeah,
1 out of 2, right? A half. Right? Let's go to Ramdas. 10.
Sir, 3 times.
Samaya, 11.
It's 12, so it's 1, 2, 3, 4, 5/12.
5. This is 5. 1, 2, 3, 4, 5. Yes, 5 out of 12. Stefan, 12. Number 12. A quarter. Taylor, number 13.
3 out of 7.
Zaya, number 14. Zaya, sorry.
2/6.
And put on the camera, please, Zaya. 2 out of 6 can be reduced to what, Zaya? Zaya.
Repeat what I said. It's not in here.
2/6 or 2/6 can be reduced to be what?
So I'm not sure.
If you have a fraction and there's a common factor, right? It all boils down to factors like what we were just doing, right? What number can go into both 2 and 6 there?
2.
Right, so you say 2 into 2 is 1 and 2 into 6 is?
3.
Right, so factors, we did factors first because I needed you to see that as factors we use to reduce these fractions, right? No, I already asked Taylor. Let me just do this one here. Anybody, what's 15? 15 is what? Anybody?
A half, sir. A half.
A half. Right, so first of all is 4 out of 8, and you can reduce it by saying 4 into 4, 1, 4 into 8 is 2, right? The common factor of 4 and 8, highest common factor of 4 and 8 would have been 4, right? So it can be reduced to be a half. And what's the last one here? Anybody? Come on, I'm going to go faster. 1 out of 6. Excellent, right? So these are my fractions, identifying my fractions, right? So one quantity as a fraction of another, right? So if I say 1 hour is divided into 60 minutes, what fraction of an hour is? So this is where we start to deal with the is over the of, right? You remember this from primary school, is over of?
Yeah, standard 4.
Right. Standard 4, all right, nice. So we have the is over the of, right? So here, 1 hour is divided into 60 minutes, right? What fraction of an hour is, so the is would be the 1 minute, right? So what fraction of an hour? So it's 1 minute out of the hour. The hour is what goes in your denominator position, right? The is the 1 minute, the of is the hour, right? But remember, 1 hour is 60 minutes, right? Is everybody clear here? This is your is, right?
Yes.
But that's I'm gonna move this a little bit. Right. So this is your is and this is your of, right? So it's is over of, right? 9 minutes. 9 minutes as a fraction of an hour would be what here? Anybody? 9 minutes as a fraction of an hour.
9 over 60.
9 out of 60. Can this be reduced here, my children?
Yes, sir.
Right. So what is the common factor of 9 and 60?
3.
3. So 3 into 9 would be 3. 3 into 60 is 20. So this will be 3 over 20. The is the 9 minutes. The of is the hour. Right? Who is not clear here? Makai, you clear here? We moving here, bro?
Yes, sir.
Right. Although we ain't started the work yet, huh? Let me remind all, we ain't started the work yet, huh? For who feeling that this is plenty work and this hard and thing, we ain't started the work yet. Ask Taylor and them about what's going on right now. Taylor, let them know now that we ain't started the work yet. Watch how he's smiling. 30 minutes, right? So 30 minutes would be the is, and it's 30 minutes of an hour. So it'll be 30 over 60. Just keep remembering this minutes we're dealing with. 1 hour is 60 minutes, right? What can this be reduced to by children? 30 over 60.
110.
1/6. Somebody say 1/6.
110.
1/10. All right, let me cancel the zeros. 3 into 3 is?
A half, sir.
All right, a half. And 3 into 6 is 2, right? So this is 1 over 2, a half. Right, guys? Everybody good here?
Yes, sir.
Right. So let me keep it rolling. I'll even some for homework. Right, so this is HW. Or they'll do this one for homework, right? There you go. So we move in. You go to school on 5 days of every week. You see all these is over off? I think I'll leave them for homework. All these is over off, you'll figure them out for homework, right? Okay, homework. All right, so I'm gonna deal with equivalent fraction. I just came out of primary school where you did heavy fractions, and even the Form 1s who roll into Form 2, you all probably did heavy fractions in Form 1, right? So, okay, equivalent fractions. Equivalent means equal, right? So the three circles on the right each have equal shaded parts or parts shaded, right? Yet are represented by different but equal fractions. These fractions, because they are equal, are called equivalent fractions. So the first fraction we have here is a half. If you look to the second partition here, you would see 2 out of 4 of the slices of the pizza are shaded, but this still represents a half. And then 4 out of 8 would still represent a half. So any fraction can be changed into an equivalent fraction by multiplying both the numerator and the denominator by the same number, right? So if I have a half and I multiply the numerator by 2, the denominator by 2, I could get a fraction that is equivalent, right, Zaya? Right. So here what? This is an important note I think I want us to write. So write this down quickly, please. Write it in your book. I've given you all 5 minutes. Quickly. Fill in the missing numbers to make equivalent fractions, right? So if we're looking at the numerators here, right, it's like 1 multiplied by some number will give me 2, and whatever I multiply that 1 by to get 2, I must multiply the denominator by also, right? So what would that number be here? Anybody?
6.
1 over 3 is equal to 2 over 6. Excellent, right? Because in order to get the 2, which is in the numerator position, I multiply by 2, which means I must multiply by 2 underneath here also, right? Raise your hand if you got that. Very good. Very good, right? So what do I multiply 10 by to get 40 here? 10 multiplied by 4. Excellent. You're seeing? Everybody seeing?
Yes, sir.
All right, good. All right, the good thing is at least it didn't delete. Everything we just did. All right, so you have all this homework. We did equivalent fractions, right? So what did we say was the answer for this? Was 36, right? 36. Okay.
Yes, sir.
What do y'all get? What do y'all get for number 3 and 4? Anybody?
So for number 3, I get 24 over 56.
24. So you're multiplying by 3 multiplied by 8 will give you 24. So you have to multiply same 8 by 8. And when you get 56, 8 8s are what?
It's 64.
64. Right. So 64 is what coming here, right? I don't like how it looking jumble up there. 3 over 8 would have been equal to 24 over 64, right? Everybody good there? So you multiply here by 8. 8 3s are 24 and 8 8s are 64. Everybody good there? And what did we multiply here for number 4? Ramo, what did we multiply in here? The question was, this was 3, 4. 22 over 55 is equal to 2. Well, we didn't multiply here. We actually divided. What do we divide by here, Ramo?
22 divided by 2. No, divided by 11.
Excellent. So 22 divided by 11 would have given me 2. So I need to divide by the same 11 here. What would it give me, Ramo?
It will give you
5, right? 55 divided by 11 is 5. 2/5, right? Raise your hand if you're good here, please. Whoop, whoop. Right. Simplify the following fraction, reduce this lowest terms. This look like homework. Right? This look like homework. You all can do that for homework, right? Right. Mixed numbers. This is what we're going to deal with next, right? So a mixed number is a combination of a whole number and a common fraction. Example, 2 and 3/5, which is red, 2 and 3/5. 27 and 2 over 9. Well, they have the wooden fit here. Also, if you have 9 and 3/6, this can be reduced to 9.5. Always reduce fractions, right? That's a very important note. Don't ever leave a fraction in a form where it could have been reduced, right? Always reduce fractions. Improper fractions. An improper fraction is one in which the numerator is larger than the denominator. From the circles on the right, we see that 1 3/4 mixed number is the same as 7/4 because you have a whole, which is 4 parts, and then you have 3 out of 4 parts. So in total, you have 1, 2, 3, 4, 5, 6, 7. It'll be 7 out of 4, right? Meaning that each circle or each pizza is cut into 4 slices. So you have 1 whole and 3/4, which is the same as 7/4. Very important, right? Simplifying fractions. All types of fractions must always be simplified, right? Never leave a fraction in a form where it cannot be reduced. I just said that, right? So all these fractions here, 6/9 can be reduced to 2/3. 2 and 5/25 can be reduced to 2 and 1/5, etc. You can't change this improper fraction to a mixed number moving forward. Now, I want us to write this as a note in our book. So I'm giving you all 2 minutes to write this quickly. I'm just gonna do like one each of these, and I'm gonna leave you all to finish the rest of the homework, right? This is standard stuff. This is stuff you probably did in like primary school, etc. Right? Okay. So we're gonna change the following mixed numbers. The following two mixed numbers. Sorry, right? So we're dealing with number 1. I just do number 1. You all will do the rest of the homework, right? So 5 could go into 7 how many times? Anybody? 5 could go into 7 how many times? 1. So you put 1 with a remainder of how much? 5, 6, 7, right? A remainder of 2. And you put it over the original denominator, which is 5. So this simply becomes 1 and 2/5 as a mixed number. The rest we will do for homework, right? So don't put HW by all next thing people say, sir, you only put HW by number 2, and that's why I only do number 2. Let's get them thinking on. Right. Change an improper fraction to, a mixed number to an improper fraction. If I have 2, and this is number 1, right? 2 and 1/5. It's a simple law. You take 5, you multiply it by 2, and then you add 1, right? So 5 multiplied by 2 would give me 10. 10 plus 1 is 11, and it will be over the original denominator, which is 5, right? So the answer for number 1 is 11/5. Homework, everybody here is homework, right? Okay, homework. Right. Okay, so we don't need to copy this down. We're moving, right? I just want to make sure that I touch on it so that when you go to do it, you are able to at least see an example of how it is done, right? Right. So comparing the size of fractions, which is larger, 7/8 or 5/6? In order to compare these fractions, we must change both fractions to equivalent fractions with a common denominator, right? So which of these fractions is larger? So this is what we have to do, right? Oh no, that's the worksheet on it, right? So we're going to get a common denominator. So I'm going to write 7/8 or 5/6. So this is why we deal with LCM and HCF before we jump into any kind of fractions, because we actually need to find the common denominator here. What is the LCM of 6 and 8? Anybody?
2.
LCM, not HCF. You just told me what my HCF is. What's my LCM for 6? Somebody say it again?
24.
24. Yes, it is 24. Now, if you're not sure, you need to go to your working column and you need to do your working to find your LCM, right? You start with 2, 2 could go into 6, you have 3 and a 4. You use 2 again, you get 3, bring down the 4, 2, 2 again. Somebody mic on 3 and 1, and then 3 to 3 is 1, right? So your LCM will be 2 2s are 4, you're multiplying coming down, right, guys? 2 2s are 4, 4 2s are 8, 8 3s are 24. So it is 24. Okay? That's a common denominator. So we're going to say 8 into 24 would be what? How many times can 8 go to 24? Anybody? How many times can 8 go to 24?
3 times.
Right. So you're going to multiply this 7 by 3 to get 7 3s are
21.
21, right? Or we ain't adding on a thing here. We're just trying to figure out which one is thing is greater, right? So 6 into 24 would be
4.
you multiply 5 by 4 to get 20. Right? So if I am asking, we try to compare the sizes of the fraction, right? So if I'm asking which one is larger, which fraction here would be larger?
7 8.
7 over 8.
Right?
7
So therefore, come here. Therefore, 7 over 8 is larger. Okay? Is everybody clear here?
Yes, sir.
Right. So we're gonna write this down. And I think this might be this one. Give me a second. Because we're gonna do all these for homework, right? All these will be homework. Hold on, I think I've given you all the additional fractions to do for homework because this is simple stuff, right? Common denominator. I might probably just do one of these here. Right, that's addition and subtraction. And at the base here, I'll give you all the try this. I wanted to finish this worksheet today, guys, but this laptop keep my back, boys. So let me go. Write on this quickly. Right? I'm gonna make it a little smaller. Y'all can probably zoom in on your end. I'm gonna put the whole thing in the frame, right? Write on this quickly. Right? Okay. So all these are homework, as I said. Let me see if I can bring this up. Hold on. I find it very low. Right. Addition of fractions. Well, these here are trivial, right? Which is part A. So we'll do these for homework. You just add in the numerators there, right? Because all the denominators are the same. Now for these, I will just do one of these here, right? So adding addition and subtraction of fractions. So if we were to do this as B, part 1, we have 2 over 3 plus 1 over 9. So what we need to do here is we need to find the LCM of my two denominators. We did a whole class on LCM last day to be able to deal with these, right? Okay. What is the LCM of 3 and 9? Anybody? What's the LCM of 3 and 9?
3.
LCM. 3. The LCM of 3 and 9 is 3. Guys, anytime you hear LCM, right? Hear this, anytime you hear LCM, it could never be smaller than the largest number. No, it's not 18. Thank you. Somebody said it. Guys, if we need to do it, we need to do it, right? If you need to go in your working column and you need to put 3 and 9, guys, do it if you need to do it, please. Right? The first prime number that could go to 3 and 9 is 3. 3 to 3, 1. 3 into 9, 3. You can do 3 again. 3, well, bring down the 1, 3 into 3, 1. So therefore, your LCM would be equal to 3 multiplied by 3, which is 9. Right? Guys, if you need to do it until you familiarize yourself with it, do your working, right? Okay? So my LCM here is 9. Okay? So let's go. So this 9 look like a G. Right. 3 into I'm doing an arrow. 3 into 9 is
3.
Right. 3 into 9 is 3. So you're gonna multiply the numerator here by 3. 2 3s are
6.
6 plus 9 into 9 would be
54.
9 into 9 is
1.
so you're multiplying 1 by 1 to get what? 1 is
1.
1, right? So to add these two fractions would actually just be 6 plus 9. Sorry, 6 plus 1 over 9. So what will this be equal to? 6 plus 1 is
7. 7 ninths.
7 over 9. This is how we solve our addition of two fractions where you don't have the same denominator. Guys, if you need to go in your working column and work out your LCM, do it for now, please. Okay? Right. So we want to add 3.5 plus 4.25. So the first thing we need to do is add our whole numbers. 3 plus 4 would give me 7. So I'm going to put a big 7 here. Then I'm going to look for my LCM of 4 and 2. What's the LCM of 4 and 2? Anyone? The LCM of 4 and 2.
4.
4, right? If you need to go in your working column to work it, go in your working column and work it, right? The LCM of 2 and 4 is 4, right? So we're going to say 2. I'm going to put my red arrow. I do this to make sure that students know what we're doing, right? So 2 into 4 would give me 2. You multiply that 2 by the denominator here. So 1 multiplied by 2 would be
2.
2 plus 4 into 4 is 4 into 4 is
1.
and then you multiply here by 1, right? 1 multiplied by 1 will give me 1. So therefore, my addition here would be 7. So this will be equal to 7, and 2 plus 1 is
3.
3 over 4. 3 over 4, right? This here is how we add a mixed number. Now points to note, but we will end up doing it next day, right? Where if we have like a mixed improper fraction here, you'll have to change it to a mixed number and then add the whole number to the 7 if it was an improper fraction, right? So here we're doing this homework. You'll have a lot of homework, but we corrected everybody in class next day. That's why when you say I give you all homework, it is excellent if you could do it before I reach here so that we wouldn't have to dwell on it too long. Right? Subtraction is basically the same thing, right? So these down here, I want you all to try them, right? Even though we did not do them, everybody should have an idea how to do it, right? Let's find it written small. Hold on, right, guys?